Hi everyone, and welcome back to Casper's dApp Developer Series. In today's video, we'll be building a dApp that accepts and authorizes whitelist requests for an NFT collection. The resulting whitelist will reside in global state and can be referenced when installing a CEP-78 contract. First, we'll write a smart contract to handle applications from users and authorization from the administrator, and then we'll write a basic React app as a user interface. Get started by opening a terminal window and navigating to the directory you'd like your project stored. I'll start from the home directory. Then run cargo, Casper, and the name of your project. I'll name mine Whitelist. Navigate into the directory and open up main.rs in an editor of your choice. I'll use VS Code. Start by importing vec and toString and get rid of the call function as we'll rewrite this. Now import the Casper types that you see here. We'll be using all these in our project. Delete key name and runtime arg name as we won't be using these, and define the following errors. Now let's write the call function that'll be invoked when the contract is installed. Create a new Entrypoints object. Our contract will have two entry points, apply and approve. Apply is for users who are applying to the whitelist, and approve is for the administrator to approve their request. Start by adding apply, which is public and accepts no arguments. Now add approve. The approve entry point will remain public, but we'll implement some logic that will prevent anyone besides the contract owner from calling it, and it'll also receive one argument candidate. This will be the user that applied that the administrator is approving. We'll need a reference to the owner of the contract, which in this case is the caller of the call function or the installer of the contract. We can then create a new named keys object and add this owner as a named key. Both our candidate list and whitelist will be represented as a vector of strings, so create two new empty vectors like so. Now create urefs referencing these vectors and add them to named keys. Create a new contract in global state with your entry points and named keys. Finally, add a reference to the contract hash under the deploying accounts named keys. Now let's write our apply entry point. First, we want to get the contract owner uref from the accounts named keys, and then read that uref to get the contract owner. Then we'll get the caller of this entry point and check if they're the same. If they are, we'll revert with the error contract owner cannot apply. We can get the candidate list and the whitelist in the same fashion. Now we'll iterate through the whitelist and see if the caller already exists in the whitelist. If they do, we'll revert with candidate already whitelisted. We'll do the same thing for the candidate list, and if we find that they're already a candidate, we'll revert with candidate already candidate. If they're not in either, we'll add them to the candidate vector and rewrite that to global state. Lastly, we must write the approve entry point. We'll start by getting the caller of the entry point. Then we'll get the candidate account that the caller provided as an argument. Just like in apply, we'll get the contract owner uref and read it to get the contract owner. In the case of approve, unlike apply, we want to check if the caller is the contract owner, and if they're not, we revert with cannot approve contract owner. Now we'll get a hold of the whitelist and candidate list just like we did in apply. Then we'll iterate through the whitelist and see if the candidate exists, and if it does, then we will revert with candidate already whitelisted. Now we'll get the candidate's index within the candidate's vector. Note that I've named this constant wrapped index as it will unwrap to none if the candidate does not exist within the vector. We'll test wrapped index against a match expression. If it unwraps to none, we'll revert with candidate has not applied. If there does exist an index, we'll remove them from candidates and add them to the whitelist. Finally, we simply write candidates and whitelist to global state, and we're done. To compile the smart contract, head back to the terminal window from earlier and run make prepare. Then make build contract. We'll need to write a small script to deploy our contract, so create a new file deploy.sh. In this file, we'll use the Casper client put deploy command, where we'll pass in the node address, chain name, in this case we'll be using the Casper testnet, the secret key, which we'll create in just a moment, the payment amount, which in this case is 40 CSPR or 40 billion motes, and the path to the compiled contract. Now save this file, exit, and create a new key pair with Casper client, keygen, and create it in the folder keys. This account will need to be funded, and since we're on testnet, I'll be using the faucet at testnet.cspr.live. If you forget how to do this, check out video 3, linked in the card above. Once the account's been funded, run chmod +x deploy.sh and run /deploy.sh. Copy the deploy hash, head to testnet.cspr.live and paste it in. Now that the deploy has succeeded, let's get started on our React app. Begin by heading back to your terminal, navigating out of the whitelist directory, and running npx create React app, and the name of your project. I'll name mine dashboard. Move into the directory and open in an editor of your choice. Start by creating the following files under src: wallet.jsx, apply.jsx, CheckWhitelist.jsx, and admin.jsx. We'll start in wallet.jsx, which will handle the functionality of the Casper wallet, and we'll create a new component named wallet. Within props will be the public key passed down from app.js, so we'll see if the public key exists, and if it does, we'll create a button that allows a user to disconnect. If there is no public key, then we will create a button that allows a user to connect to the Casper wallet. Now we'll write the request connection function that you can see here. This will tap into the Casper wallet provider and execute request connection. If it does connect, then we'll call the function getActivePublicKey, which we'll write in just a second. Note that when we write app.js, we will instantiate the Casper wallet provider and pass it down through the props. Now we'll write the disconnect function that you see called here. All this will do is call disconnect from site on the Casper wallet provider, and if we disconnect successfully, then we'll set the public key to null. Note that public key and set public key are part of a React state variable that we'll define in app.js. Now we'll write the getActivePublicKey function that we called in request connection. All this will do, we'll call getActivePublicKey on the Casper wallet provider and then set the public key with setPublicKey. That's it for wallet.jsx. Let's head over to apply.jsx. First, import runtime args, CL-public-key, and deploy util from the Casper.js SDK. Now write the apply component, which will simply return a button that calls apply, which we'll write next. Create the function apply, which accepts props and is asynchronous. First, check that the public key exists in the React state, and if it does not, return out an alert with no public key found. Please connect to the Casper wallet. Create an empty runtime args object. Build a deploy object with contractClient.callEntryPoint. We'll also be creating this in app.js like we've been doing before. We'll call the entry point apply with our empty runtime args object. We'll pass in the public key that we build from the props.publicKey string. We're on the Casper testnet, and we'll define our gas limit, which in this case is 4 CSPR or 4 billion motes. Convert this deploy object to a JSON representation, then open a try-catch block. Forward the deploy to the Casper wallet with provider.sign, passing in your stringified JSON deploy and the public key of the signer. Check if the signature request was canceled by the user, and if it is, alert and return out. Apply the signature to your deploy object from earlier. Convert this new signed deploy to another JSON representation. Now post this deploy to the backend at the endpoint deploy. We'll write this functionality when we're finished with the front end. Check the response from the backend. If we get an error, we'll throw a new error here, and this will be caught in catch. Assuming we get a successful response from our backend, we'll alert the user with the response, which will be the deploy hash of the deploy. If we encounter an error, we'll just notify the user with an alert. That's all for apply.jsx. Let's move on to admin. Start by importing CL-public-key, CL-value-builder, runtime args, and deploy util from the Casper.js SDK, and import React. Create a new functional component admin, which accepts props. Create the following React state variables. We'll use contract owner to identify the administrator, mode to define whether we'll be dealing with candidates or the whitelist, and the candidates and whitelist themselves. Check if contract owner is equal to null. If it is, call getContractOwner, which we'll write in a second, passing in setContractOwner, which we defined here, and return verifying contract ownership until we get a result. If the contract owner is not null, we check to see if it matches the user's active public key, and if it does not, then we inform the user that they are not the administrator and provide them a button to go back. By calling setAdminNull, this will kick us out of the admin page and bring us back to the main menu. We'll write this functionality in app.js. If we pass both of these if statements, we know that the user is the contract owner, and then we then check if mode is equal to null. In here we return two buttons, allowing the administrator to select whether they'd like to view the candidates or the whitelist. If mode is not equal to null, it must either be candidates or whitelist, as we see here. If the user selected candidates, then we check if candidates is equal to null. If it is, then we get this list of candidates, which we'll write in just a second, and we return a label loading candidates. However, if candidates is not equal to null, then we know candidates must exist, so we return a function build.jsx, which we'll write in a moment, that prepares the list of candidates in JSX. You'll also notice we pass in another function approve, which we've also yet to write, that will handle submitting approval deploys. We do the same thing under the whitelist mode, however in this case we don't provide approve to build.jsx, as the administrator has no need to approve already whitelisted accounts. We're done with the component itself, so now we can write the getContractOwner function, which we call here. Open up a try-catch block, and fetch the contract owner from the backend at the endpoint contract owner. Check that the response is successful, and if it's not, throw a new error. If it is successful, call setContractOwner on the result. If we receive an error here, just log it out to the console. Next is the getList function, which either gets the list of candidates or the whitelist. Open up another try-catch block. Call the backend at the getEndpoint getList, and in this case list can either be whitelist or candidates, so provide that as a flag. Now, like we've been doing before, check if the response is okay, and if it's not, throw a new error. If the query succeeded, set the list with setList. And if an error occurs, just print it to the console. We're done with getList, so now we can write the approve function, which handles calls to the approve entry point in our smart contract. Create a new runtime args object, providing the candidate as a string. Now prepare the deploy just like we did with apply, except calling the approve entry point. Now simply copy the deployment functionality from apply, as it'll be the exact same. Finally, we can get started on the build.jsx function. First, check if the list of accounts is empty. If it is, return a header that says mode is empty. This will either be the string candidates or whitelist. If accounts is not empty, return a new unordered list. Map the accounts variable to execute this block for every account. Then create a list item for every account and provide a button that allows the administrator to approve only if the mode is equal to candidates. We're done with admin, so move on to CheckWhitelist, which will allow a candidate to see if they've been approved. Create a new component CheckWhitelist, which just returns a button that calls the CheckWhitelist function, which we'll write next. Create this CheckWhitelist function, which accepts props and is asynchronous. Check if props.publicKey is equal to null, and if it is, alert the user and return out. Open a new try-catch block. Call the backend at the getEndpoint CheckWhitelist and provide the public key as a URL parameter. Like we've done before, check if the response is okay, and if it's not, throw a new error. If response.text does not contain error information, then we must have successfully gotten the result. We check if the result is true. If it is, the user is on the whitelist. If it's false, they are not on the whitelist. Lastly, simply log out any errors to the console. CheckWhitelist is finished, so save the file and open app.js. This is the last file we'll be working with on our front end. Delete import logo and add the following imports. We'll need React, wallet, apply, admin, CheckWhitelist, and then Casper client and contracts from the Casper JS SDK. Go ahead and delete everything in the return statement and create two new React state variables, public key and mode. This public key is the variable that will be passed down through our props and accepted by our components. Note that this mode is different from that in the admin component and will determine whether we are in admin or user mode. Create two new variables to reference the Casper wallet provider and Casper wallet event types. If either of these are equal to null, we know that the Casper wallet is not installed because the Casper wallet injects these into the browser. Initialize a new Casper wallet provider object. Create a new Casper client object as well as a contract client. Note that you'll need to replace node address with the node address you'll be using. Define the contract hash, which you can get by going to testnet.cspr.live, heading to your account, going to named keys, and copying the contract hash. Set the contract hash to the contract client. Create a new empty JSX component that will manipulate depending on the mode and the public key. First, check if the public key is equal to null, and if it is, the component we'll return will be wallet. If the user has already signed into the wallet, meaning the public key is not null, we'll then check if the mode is equal to null. If it is, we'll ask the user whether they want to go to the admin page or the user page. If the user selected admin, it'll set the mode to admin, so we'll check if the mode is equal to admin. If it is, we return the admin component. On the other hand, if the user chose the user mode, then we will return the apply component and CheckWhitelist. Now we'll create a navbar component that'll allow the user to navigate backward through the application. If the public key is null, then we are on the main menu and don't require a navbar. However, if the public key is set, we should create a navbar that handles backward navigation, and we'll also list out the user's public key for convenience. Finally, we return the navbar and the component. Note that the navbar may be empty if the public key is equal to null, so nothing would show up here. Lastly, we just need to create our handle back button pressed function, which will perform different actions depending on where the user is in the application. If the mode is equal to null, then we know we've only yet set the public key and can go back to the main menu. If mode is set, however, then we may just set the mode to null and go back to the mode selection menu. That's it for our front end, so save app.js and create a new file server.js in your project's root directory. We'll be using Express to serve our backend, so import Express and create a new Express app. Also import cores, as we'll be using this to communicate with the front end. Then import Casper client, contracts, CL public key, and deploy util from the Casper.js SDK. Tell your Express app to use the JSON and cores modules. Just like on the front end, create a new Casper client object and Casper contract client object. Set the contract hash to the same contract hash you used in app.js. Now create a new post endpoint deploy that will accept an incoming JSON deploy and submit it to the network, returning the deploy hash to the front end. Open up a new get endpoint get list, which will either get the candidate list or the whitelist. First, ensure that the user included the list flag and that it's equal to candidates or whitelist. If it's not, send a 400 error. Open a new try catch block and get the proper list from the smart contract. Assuming no errors occur, we'll iterate through the list and push the data into a new list. Now stringify this list of JSON data and send it back to the front end. Open the CheckWhitelist get endpoint. Make sure that the public key is provided in the query. If it's not, send a 400 saying no public key provided. The user's account will be recorded as an account hash, so we need to convert the public key to an account hash string. Open up yet another try catch block. Query the whitelist from the contract. Now iterate through the whitelist and see if we find the account hash within the whitelist. If we do, we set found equal to true, and we send that back to the front end. If found remains false, then the user is not part of the whitelist. We can also add a break here, because if we find the account hash, then we no longer need to check. Finally, we just need to create the contract owner get endpoint, which will just get the contract owner from the smart contract and send it back to the front end. All that's left is to serve our application, which we'll do on port 3001. Our application is now complete, so we can save server.js, head over to a terminal, and install the required packages. We'll install cores, Express, and the Casper.js SDK. To run the application, we'll first run node server.js, and then we'll open a new tab, and that should be in the same path, and we'll run npm run start. We have a small error here, and that's because I forgot to convert our deploy to a JSON in admin.jsx before the try block in the approve function. We can now save this file and head back to our browser, and you see our app works properly. Your app will not look like this because I've added custom CSS. Your app will instead look like this. However, I will include minified CSS in the description for you to copy and put into app.css, and this will fix the issue. Begin testing by clicking Connect to Casper Wallet, which will bring up the Casper Wallet. I'll connect with the owner of the contract, connect to the account, and you'll see the public key here. Since this account is the contract owner, we should be able to go to Admin, verify the contract ownership, and then click on Candidates or Whitelist, which should both be empty. Let's now connect to another funded account so we can test the user functionality. We'll first test to see if admin works, which it should not. Then we'll click user and check whitelist. We should see that we are not yet on the whitelist. Now let's apply for the whitelist. Click apply. This will bring up a transaction. Sign the transaction, copy the deploy hash, head over to cspr.live and paste it in. Once the deploy has succeeded, we can head back to our React app, change the account to the contract owner, refresh, connect to the Casper wallet, go to admin and candidates, and we should see the one candidate. Now let's approve the candidate with this account, sign the transaction, copy the deploy hash, head back to cspr.live and paste it in. Now that the deploy has succeeded, we can head back to our app, go back, click admin, and we'll notice that there is no longer anyone in candidates. However, there should be the same account hash within whitelist. We can check this from the user's perspective by going back to the whitelisted account, refreshing, connecting to Casper Wallet, clicking user, and check whitelist, and we should see that we are on the whitelist. That's it for this video. If you found it useful, hit the like button and subscribe to see new dApp Developer Series videos as they are released. In the next video, we'll create a whitelisted NFT collection using the whitelist we created today, so stay tuned. Thanks, and I'll see you in the next video.